All right, today we are diving into something pretty cool, a really unique approach to teaching math. We're going to break down how one lesson plan uses, believe it or not, ancient history and philosophy to answer a question that feels very, very modern.
And we're going to start with this question. I'm pretty sure every single one of us has asked this in a math class at some point. It is the universal cry of students everywhere when they're staring at abstract formulas that just feel completely disconnected from real life.
Well, it turns out we're looking at a 6th grade lesson plan today that tackles this question head-on. It doesn't just dismiss it. It offers a story-driven answer that's designed to make math feel important and, purposeful.
So what's the secret sauce here? What's the big idea? Well, instead of just throwing formulas on a whiteboard, this lesson actually starts with a core philosophy about why math matters in the first place.
And here it is. The central idea is pretty fascinating. It connects math not just to practical everyday problems, but also to this moral framework of making wise decisions. By drawing this direct line to biblical stories, it tries to give every single calculation a much deeper meaning.
Okay, that sounds great in theory, but how does it actually play out in a math problem? Let's take a look at how this lesson translates that big idea into some concrete examples.
So the first problem comes directly from the lesson's main source of inspiration. Students are asked to find the total area of a courtyard for the tabernacle, and they do it by combining two different rectangular sections.
As you can see, the problem is broken down into two super simple parts. The math itself, it's easy, right? Calculating the area of a couple of rectangles. The point here isn't the difficulty. It's how these simple calculations are framed as steps in a much larger historical building project.
You add them up and boom, 48 square units. It's a simple formula, but now it's tied to a specific narrative goal.
Next up, the lesson jumps from the ancient world right into a modern one, building a swimming pool. And this is to show how the same principles apply, but this time to the concept of volume.
And again, the numbers are super clear. You've got a base area of 30 square units and a height of 10 units.
Which gives us a total volume of 300 cubic units. See what the lesson's doing here? It's making it really clear that the same mathematical rules apply, whether you're building an ancient tabernacle or a modern pool in your backyard.
The final example in the lesson plan throws a new shape into the mix, the triangle. In this scenario, students have to calculate the combined area of two triangular fields.
So using the standard formula for a triangle's area, they figure out that each field is 24 square units.
And since there are two identical fields, the total just comes to 48 square units. It's another direct application of a core formula, but in a practical scenario.
Okay, so we've seen the math problems. They're straightforward. But this is where it gets really interesting. Let's look at how the lesson connects this need for mathematical precision to a much deeper theological idea.
The entire lesson really pivots on this one quote from Exodus. That phrase, the pattern, that's the key. It suggests that following a divine blueprint requires absolute, uncompromising mathematical precision.
And here's where the lesson just lays it all out. It draws this direct parallel. The need for precision in following the tabernacle's instructions is presented as being just like the care you need when applying mathematical formulas. In both worlds, accuracy is everything. So, how do you test this knowledge? Well, the homework assignment kicks it up a notch by bringing inequalities into the picture. The homework sets up this really practical problem with a constraint. A total tile area must be under 90 square units. This little shift from finding an exact answer to finding a maximum limit is the perfect setup for using an inequality. And the solution is laid out in three really logical steps. First, what's the goal? Keep the area under 90. Second, how do you write that in math terms? 6x is less than 90. Third, you solve for x. But the really clever part is that final insight, translating x is less than 15 back to the real world. You can't use a fraction of a tile, so the maximum number you can use is 14.
So, after looking at the examples and the philosophy behind it, what does this unique teaching method really show us about learning itself?
When you really boil it all down, this method is fundamentally about adding context. By connecting abstract formulas to tangible stories, it provides a moral and historical anchor for why precision matters. It's a powerful attempt to finally answer that why behind the how, and it uses narrative as a tool to make the concepts unforgettable.
And that leaves us with a bigger question to think about, not just for math, but really for any subject. How does the story we wrap around a piece of information ultimately change the lesson we actually learn from it?